Good evening, everyone. I am Palash Kumar Mistry, final year undergraduate student, Department of Chemical Engineering at NIT Durgapur. Today, I am going to teach you the thermodynamics topic, which is a very important topic of your IIT JEE purpose. So, before going into detailed discussion about thermodynamics, at first I want to give you a small idea what is thermodynamics. Basically, thermodynamics is a science which deals with energy and its transformation. Basically, it's tell about the relationship between heat and work. So what is thermodynamics? Thermodynamics is the relationship between heat and work. Basically it tells about the relationship between heat and work. So thermodynamics has two approach. One is microscopic approach, and another one is macroscopic approach. So what is macroscopic approach or microscopic approach? Macroscopic approach. Macro means we are not dealing about the at molecular level. We are just dealing about the overall behavior of thermodynamics. So that is the macroscopic approach of thermodynamics. It is basically classical thermodynamics. And what is microscopic approach thermodynamics? In microscopic approach thermodynamics, we are dealing at molecular level of thermodynamics. So these are the concept about microscopic approach and macroscopic approach. Now comes into the thermodynamics very key important terms, and these are: first one is system, second one is surrounding, or third one is universe. So now what is system? Let's take an example. This is a process where any reaction happens. This process is called system, and the imaginary surface which is surrounded by the system is called boundary. This is boundary, and the outside is surrounding, and the system plus surrounding is called universe. This is the concept of system, surrounding, and universe. Basically, what I am trying to tell you, system is what you have assumed one closed container or something, which is where any reaction or something is happening. This closed container is called system, and it is closed means it is surrounded by a thin layer or something which is called boundary. It's imaginary or real also. Okay, and outside of the boundary is called surrounding, and system plus surrounding together is called universe. Okay, previously we have discussed about system, surrounding, and universe. Now I am going to discuss about types of system. So the types of system. System has three types. One is open system, another one is closed system, and the third one is isolated system. So now we are going to discuss about open system. So for this I am drawing a system where mass enter and also mass will released. Here also energy in, energy out. This is a system. So what tells about what is open system? Means in open system means where both mass and energy can transfer into the system. means mass in and mass out, and energy in, energy out, both happens together. This system is called open system. Now tell us about closed system. What is closed system? Closed system is a system where only energy can transfer but mass cannot transfer. That means this is a system where only energy can transfer but mass cannot transfer. This type of system is called closed system. And the example of the closed system is any reaction happen in any reactor, means closed reactor, or like piston cylinder, frictionless piston cylinder. Here I am assuming a frictionless piston cylinder. This is a closed type system. Okay. And open time system means any system which is where energy and mass both can transfer. That's called open time system. And open time system is also called control volume. Okay, this can this is a one important term of open system. Now I am discussing about isolated system. So basically, what is isolated system? Means where energy and mass both cannot transfer. This type of system is called isolated system. But in real, any system is not an isolated system, means there has no existence about isolated system. So one example of isolated system is ideal thermoflux. Where energy and mass both can pass togetherly. Now let us talk about various process of thermodynamics. So thermodynamics process. First come isobaric process. What is isobaric process? Means where pressure is constant. It is a process where pressure is constant. This is called isobaric process. Now next come isochoric process. What is isochoric process? Isochoric means where volume is constant. Means volume is constant. This type of thermodynamic process is called isochoric process. Now isothermal process. What is isothermal process? Where temperature is constant. It is a thermodynamic process where temperature is constant. This type of process is called isothermal process. Now the next process is adiabatic process. What is adiabatic process? It is a thermodynamic process where heat cannot transfer. Means dQ, transfer of heat will be 0. Okay, this type of thermodynamic process is called adiabatic. Now I am discussing about cyclic process. So what is cyclic process? Cyclic process is a thermodynamic process where after changes of some operation, it's again come to its initial point. That means where initial and final point both are same. Means here initial point will be there and also final point will be there. This type of system is called, or this type of process is called cyclic process. Several thermodynamics properties like mass, enthalpy, entropy, temperature, pressure, etc. are there. So based on thermodynamics property has two types. Based on this, thermodynamic property has two types. One is extensive property, another one is intensive property. So one is extensive property. And another one is intensive property. So now coming to the point of extensive property. So what is extensive property? Extensive property are this type of property which is dependent on the mass of the system. This type of property is known as extensive property. The example of the extensive property is mass, volume, enthalpy, internal energy. These all are extensive property. And now comes into the point of intensive property. What is intensive property? Intensive property are thus thermodynamic property which is independent of the mass of the system. And this type of property is called intensive property, like pressure, temperature, etc. So here one point you have to remember, the point is density is intensive property. Density is intensive property. Why density is an intensive property? Density is the ratio of two extensive property. Means density. What is the formula of density? Density formula is kg per meter cube, means mass by volume. Mass and volume both are extensive property. So the ratio of two extensive property is known as intensive property. Okay, now we are going to discuss about the various law of thermodynamics. So there are 4 laws in thermodynamics. First is zeroth law of thermodynamics, second is first law of thermodynamics, third is second law of thermodynamics, and fourth is third law of thermodynamics. So laws of thermodynamics. First comes zeroth law. Basically, first comes first law, but later zeroth law was invented, so that's why it's coming first. So zeroth law tells? Zeroth law tells about the thermal equilibrium concept. Like suppose to say A, B, C. Three substances there. A is thermal equilibrium with B, and B is thermal equilibrium with C. Then there is a chance of A is thermal equilibrium with C. This is the concept of zeroth law of thermodynamics. Now comes into the first law of thermodynamics. Basically, what is first law of thermodynamics? First law of thermodynamics tells about the conservation of energy law. So first law of thermodynamics. So what is first law of thermodynamics? First law of thermodynamics is energy can neither be created nor be destroyed. It can convert from one form of energy to another form of energy. This is called first law of thermodynamics. Okay. So the first law of thermodynamics tells about the conservation of energy, means energy can neither be created nor be destroyed. It converts from one form of energy to another form of energy. So I am giving you one example. Let's say it's a flow system, piston cylinder system. Some heat is added here. So heat converted into another form of heat, or energy converted into another form of energy. So here some work done will be there, means some work done by the system, and some amount of changes of internal energy will be there. So the first law of thermodynamics is Q equals to delta U plus of W. This is the statement of the first law of thermodynamics. Now comes into the second law of thermodynamics. Now comes into the second law of thermodynamics. So second law of thermodynamics has two approaches. First is Clausius approach, and second one is Kelvin-Planck statement. What tells about the Clausius statement? Clausius statement tells about heat cannot itself pass from a cold body to hot body, and the Kelvin-Planck statement states that heat cannot convert it fully into work, means 100% of conversion of work is not happens. Basically it is the second law of thermodynamics. Okay, so one is Clausius statement and another one is Kelvin-Planck statement. So what Clausius statement states? Clausius statement states that heat cannot itself pass from cold body to hot body, and Kelvin-Planck statement states that the heat cannot fully convert it into work. Okay, there's this statement of the second law of thermodynamics. Now comes into the third law of thermodynamics. Okay, so now comes into the third law of thermodynamics. So what the third law of thermodynamics state? Third law of thermodynamics state that the absolute entropy of a pure crystalline substance is zero at absolute zero temperature. Okay, so this is all about the basis of thermodynamics in a nutshell, and thank you.